Right, so dividing out and rationalizing techniques. An expression such as 0 divided by 0 is called an indeterminate form because you can't find the limit, you can't determine the limit from the form alone. When you try to evaluate a limit and you encounter this form, so the numerator goes to 0 and the denominator goes to 0, remember that you must rewrite the fraction so the new denominator does not have 0 as its limit. Right? So we have to fix the denominator. One way to do this is to divide out like factors. So we've divided out like factors, right? We factored and then we canceled them out. We rewrote fractions and reduced those. Sometimes we're going to have radicals. And if we have radicals, another way is to rationalize our numerator. Right? So we change it, right? So we don't have, if we have a radical in the numerator, we rationalize to get rid of the radical in the numerator. So let's take a look. So rationalizing is going to help us when our numerator goes to 0, our denominator goes to 0, and we have a radical. All right, so here if we want to find the limit of the square root of x plus 1 minus 1 divided by x as x goes to 0. So notice that if we plug in 0, the numerator is going to 0. The denominator is going to 0. So direct substitution fails because we have some factor that's in both the numerator and denominator, but it's hidden. It's hiding. Right? So we're going to rewrite this fraction by multiplying by the conjugate. You're going to use conjugates as a way of making the terms disappear. And in essence, they'll look different. And we'll be able to find out who our problem is. Remember the conjugate? Same values, just change the sign. Right? So we're going to multiply the numerator and denominator by square root of x plus 1 plus, instead of minus, 1. And you have to do that to the numerator and the denominator. Oh, don't you love the orientation on the board? Ooh, wavy, pretty. Now, I want to simplify the numerator, and multiplying by the conjugate will do that. In the denominator, I don't want to distribute the x. That might just hide my repeating factor once more. All right? So we want to simplify that numerator because that's what the conjugate's going to do, but we won't distribute it in the denominator. So we're going to have the limit as x approaches 0. So here our step was we multiplied the numerator and the denominator. There we go. By the conjugate. That's and. I don't know what that looks like. Right? And so when we do that, so we have the square root of x plus 1 times the square root of x plus 1. That's just the square root of x plus 1 squared. Now remember I went over multiplying if I believe on one of the lessons we talked about what happens if I multiply by conjugate. The middle terms are going to be opposites, right? So I'm just going to write this and then I'll just erase it, right? So on the outside I'd have, actually I'll keep it for this one, but I'm not going to do it again. Right, on the outside I'd have 1 times the square root of x plus 1. On the inside, right, because I have to multiply all my terms. Either you can think of it as distribution, right? Everybody in the first one, you're going to multiply in the second binomial. Or you can just think of it as FOIL. The first 2 terms, the outer 2 terms, the inner 2 terms, the last 2 terms. That's nice if you don't want to rewrite it. Right, so then we have plus a negative 1 times x plus 1. And then we'd have the last terms, negative 1 times 1. So that would be negative 1. So notice, and this will happen every single time with the conjugate, I have opposites. Notice those 2 middle terms. So I have the square root of x plus 1 minus the square root of x plus 1. Guess what that's going to be? Well, 0. So for this one time and one time only, I'll write those middle terms, and never again am I writing them, right? Because we know they're just always going to be 0. That's a property of the conjugate. right? Essentially, this is like a difference of squares, right? And if you multiply something minus something and then the same something plus something, right? And for your difference of squares, you'll have a something squared minus a something squared, and all the middle terms disappear. All right, so we have the limit as x approaches 0. The square and square root would cancel, right? So always the square root times the square root is just going to give me the inside stuff. So in the next lesson, in the next problem, we'll just write the inside stuff, right? Because if we're multiplying something by itself, we have something squared, right? And the square and square root will cancel. So it's just going to leave the x plus 1. The rest of that, whoops, what happened to my 1? The rest of this is 0 in the middle there. And then the only thing we have left now is the minus 1. So we can essentially just write this minus, so this squared minus this squared, because that's what it's always going to look like. But I thought I would just go over it on this one. All right, and then I'm not going to distribute in the denominator x times the square root of x plus 1 plus 1. So now notice we have, all right, so all we did so far is multiply the numerator and denominator by the conjugate. Then let's simplify. So that's going to give us just x. Oops. The limit as x approaches 0, because the function itself, right, would never be 0, right? X would never be 0, right? Because that would make the denominator 0, right? So the limit as x approaches 0 of x divided by x times the square root of x plus 1 plus 1. So notice there's our problem, right? So we're going to be able to reduce. And then we'll be able to substitute into the reduced equation. And so these will always be our steps. All right, so we have the limit, and let's just cancel this out. There we go. So we have the limit as x approaches 0 of 1, and now you can see what we didn't distribute. Square root of x plus 1 plus 1. So now that would just be 1 divided by the square root of 0 plus 1 plus 1. Well, that's just 1 plus 1, right? Because the square root of 1 is 1. And so that would be 1/2. So that's our limit, 1/2. All right? So, all right, it's a little bit of work, but I did some steps I didn't need to, like writing the middle terms. Right? And, but the work itself really is not that difficult. And it gives us our limit. All right? So if you've got a fraction, and both the numerator and denominator are going to 0, and there is a radical, you're going to multiply by the conjugate. Let's do some more. Oh, first of all, let's look at the function. So here it is graphed. So we have f of x equals the square root of x plus 1 minus 1 divided by x. All right, so if you look at a graph, that can also make you feel, yes, I got that right. So the limit of f of x as x approaches 0 is 1/2. And notice we have a whole, right? So some of you are confusing the value of the function with the limit of the function. So f of 0, that's the value of the function. That doesn't exist. But it doesn't have to for the limit to exist. The limit as x approaches 0 of this function is 1/2. So limit, yes, that exists. Value of the function, no, that doesn't exist. We have a hole there, right? Because that makes the denominator 0. But you don't have to have your function to exist to have your limit to exist. All that has to happen is that the value you're approaching from the left has to equal the value you're approaching from the right. When we're looking at graphical limits, we'll look at a graph to make sure that is true. When we're working with problems like this, right, we're going to be using algebraic techniques, and if we have a form that we can substitute into, right, even though we know the point can't exist because we have that hole there at 0, and we can see we have to have a hole at 0 because we canceled out x divided by x. So even though there's a hole there and we can't plug into it, if we can we can substitute into the reduced form, then that will be our limit, and that will be okay. And we won't need to use a graph necessarily to find the left and the right-hand limit, but it is good to be able to use that to just, reassure yourself, and as just another way to show that, yes, this limit is 1/2. All right, let's do another one. And that's this one here. All right, so we're going to, let's take a look, because if I can just plug in, I'm not going to, be rationalizing if I can just plug in, but we can see, the denominator, that's going to be a problem, right? That's, if I plug in 0 into x, that's 0. How about the numerator? Well, that would be the square root of 0 plus 2 minus the square root of 2. Well, that's just 0. All right, so both the numerator and denominator, they're going to 0. All right, so that means this is an indeterminate limit. We have a fraction. So let's rationalize this numerator and multiply by the conjugate, and then we will be able to use substitution. So we have the limit as x approaches 0 of square root of x plus 2 minus the square root of 2 divided by x times square root of x plus 2 plus, opposite sign, square root of 2, and then of course we need 2. Square root of x plus 2 plus 2. All right, so that's going to give us the limit as x approaches 0. We're going to end up with the square root of x plus 2 squared, right? Those middle terms are going to drop out. And then we're going to have minus, right, because we have a negative and a positive, the square root of 2 squared. Right? So only things that will be left will be the first and last terms, right, squared, all over x times the square root of x plus 2 plus 2. Oops. Sorry. He needs to be under the radical there. All right, so now that's just, we'll just simplify that. That's the limit as x approaches nothing right here. That's an arrow. No, that's so good, huh? So the limit as x approaches 0, we have now square and square root cancel. That's just an x plus square root of 2 squared. That's just a minus 2. And the denominator, we have x times the square root of x plus 2 plus the square root of 2. Well, now we can see the problem, because we have the limit as x approaches 0 of x divided by x times the square root of x plus 2 plus the square root of 2. So those x's will cancel, right, because those are two factors. Hence the reason we don't want to distribute the x, because then it won't be a factor. That would give us the limit as x approaches 0 now of 1 divided by the square root of x plus 2 plus the square root of 2. Right, now you can plug in 0 all you want. Right, and we get 1 divided by the square root of 0 plus 2 plus the square root of 2. Well, that's just, we got 2 square roots of 2 now. So that's just 1 divided by 2 square roots of 2. Or if you want to rationalize it, you could write it as, right, so you multiply the numerator and denominator by the square root of 2, or square root of 2 times, or divided by 4, right? Because in either, I don't care if you rationalize. If it's a multiple choice question and it's rationalized, well, you'll have to rationalize it. Otherwise, I don't care. Right, so this would be the square, I'm not on this problem. This would be the square root of 2, and then we'd have square root of 2 times the square root of 2, that's 2, and 2 times 2 is 4. So either is fine, 1 over 2 square roots of 2, or square root of 2 over 4. Either is fine with me. Let's see, do we have another problem for us? I don't. So I think, though, we did, what did we do, 2 or 3 there? We did 3, I think. So I hope that will be enough for you. And if not, I'll be happy to help you with these or do more problems for you. All right, so just remember, numerator and denominator go to 0. That's an indeterminate limit. And now you've got 3 techniques depending on what the problem looks like. If it has a radical, you're going to rationalize. If it has fractions, you're going to combine, you're going to get a common denominator and combine the fractions. And if it's not one of those two, and it's a polynomial in the numerator and denominator, well, then you'll factor and you'll cancel the repeating factor. Right? But now you've got 3 ways to deal with these. All right, so thanks for watching. You can do the whiteboard practice, and I'll see you in the next podcast. Bye for now.